Welcome back to our lecture series on getting started with Astronomy 20. Right now, what we're going to do is we're going to go through our cosmic address, and I'm going to do this in two parts. So the first part is going to talk about our place in the solar system, and then the second part is going to talk about our place in the universe. So this lecture was written for an in-class sort of situation, and I really haven't adjusted it because basically we've all been to El Camino College or are perhaps familiar with the average size of a school campus, so I still think that this is a fairly good walk through. We all know where El Camino College is at any rate, so this will give us a good idea of sort of where we can find, the normal classroom. So I'm going to ask the question, where are we, several times here. And we're going to start small and we're going to zoom out in very small chunks. So if we were taking this class at El Camino College, we would be in the El Camino College Planetarium. Great building, by the way. If you've never been to a planetarium show, when all of this craziness is over, you should definitely check them out. The planetarium is amazing, and it's really a shame that you're not going to be seeing the planetarium in use during this online course. But more importantly, what we want to do is we want to establish a sense of scale. So if you've been in any classroom, you're probably aware that a classroom is a few meters wide. I think I did a measurement on the planetarium when I first wrote this lecture series, and I measured it to be about 14 meters across or something like that. So, it's an average size room. It's not very big. It's not, it's an average size classroom. But zooming out, so where is the planetarium? Well, the planetarium is on El Camino College campus. And if you were on campus, and so perhaps you've been on campus, but if you're new, this probably isn't a good point of reference for you, but just think of any school campus. So from the McDonald's to the opposite side of campus, so from one corner to the other, is just short of a kilometer across. So when we're talking about a kilometer, I want you to think it's about the size of a school. For those of you who run for fun, 5 kilometers is about 3 miles. So that's something that you probably have in your head if you are a runner, because a 5K is roughly 3 miles long. But for everybody else, me included, just think it's about the size of a school campus. All right, so where is El Camino College? El Camino College is in Torrance. Torrance is the city. And then, of course, if we zoom out even farther, Torrance is in the county of Los Angeles. So here we're still in the sort of kilometer range, right? So all of Los Angeles is going to fall into somewhere on the scale of about 100 kilometers. 10 kilometers, by the way, is about the distance from El Camino College to the beach. So this is a very nice scale, but once we start going out further and further, I want you to start keeping these scale lengths in mind, just because we're going to get to some really big scales here, and it's going to be necessary to think about this in a way that we can relate to normal distances here. So California is what comes next, right? So LA County is in the state of California. And California is nice because California is long and skinny. So it makes sense to talk about the length of California. If you measure north to south, California is almost exactly 1,200 kilometers across. So 1,200 kilometers. So if you wanted to walk the length of California, that would be starting at the McDonald's, walking across campus, and then walking back to the McDonald's 600 times. So it's 1 kilometer one way, 1 kilometer back. Do that 600 times, you get 1,200 kilometers, 1,200 kilometers. I plugged this into Google Maps, and Google Maps tells me that this is 278 hours of walking, which is about a week and a half of nothing but walking. So that's no breaks for the restroom, no breaks to eat, no breaks to catch your breath. Just if you started at the bottom and walked for a continuous 1.5 weeks, you'd get to the other side of California. California is long and skinny, like I said, so it's nice to think of this as like a unit of measure. How many Californias is something? All right, we zoom out even further, and California is located in the United States of America. So the US is 4,500 kilometers across. California, remember, is 1,200. So this is 3 Californias and a little bit. So starting from the East Coast, if you walked toward the West Coast, it'd take you about 3 times the length of walking California north to south. So we said it took a week and a half to walk from one end of California to the other. It would take you 3 times that length. So that is 4.5 weeks, so about a month, to travel from one side of the United States to the other if you just started walking and didn't stop. So this is our address. Our address is Planetarium at El Camino College, 16,007 Crenshaw Boulevard. City is Torrance, state is California, and we're in the United States. And of course, if you wanted to get a postcard delivered to the planetarium, you need to include the zip code 90506. So I bet you're wondering why we did all of that math in the previous section. Like, why did I bother teaching you math? It doesn't look like it's coming up yet. We're about to get really big. The amount of distance is about to take a huge jump from the size of the United States, which is, 4,500 kilometers, to the next thing up. So we could, of course, talk about continents. But the United States stretches from one side of a continent to the other, so there's no real need to make that jump. Let's just go all in on planet Earth. So planet Earth has a diameter of 1.27 times 10 to the 4 kilometers. So planet Earth is 12,000 kilometers. California is 1.2 times 10 to the 3 kilometers. It's 1,200 kilometers. So if you took California, turned it sideways, and stacked them end to end, it would take 10 Californias to stretch the length of the diameter of planet Earth. So planet Earth is really big. It's an order of magnitude, we say, bigger than the size of California. So that word, order of magnitude, specifically means it's 10 times as big. So 10 Californias fit on the diameter of planet Earth. So the planet Earth is an order of magnitude bigger than California. And here's where we're going to take a huge jump. So we're going to go from 12,000, 1.2 times 10 to the 4, and we're going to make a jump. So the jump here that we're going to make is the size of the distance from Earth to the sun. So from Earth to the sun, I want you to take a guess at this distance. How big do you think this is? All right, so from Earth to the sun, it's actually 150 million kilometers. 150 million. So 1 million is 10 to the 6, but this is 150 million. So this is 1.5 times 10 to the 8. 1.5 times 10 to the 8. California was 1.2 times 10 to the 3. So this is 5 orders of magnitude bigger. Just to give you an idea of how big that is, you'll remember that El Camino College is 1 kilometer across, and the Earth is, in diameter, the Earth is 10 to the 4, right? So that means the Earth is 4 orders of magnitude bigger than El Camino College. So if you have El Camino College as your size on one side of the Earth, and you walked to the other side of the Earth, like, that size difference between El Camino College and the diameter of Earth is still smaller than the size difference of Earth versus the distance to the sun. The sun is really, really far away. In fact, it starts becoming a little bit hard to think about these distances. So we don't talk in kilometers anymore. There are too many things going on here. If we kept talking about kilometers here, this number is just going to get so big it's meaningless. So instead, we call this distance 1 astronomical unit. And when we talk about other planets, we talk about how far away they are from the sun in terms of astronomical units. So 1 astronomical unit is the distance from Earth to the sun. Neptune is 30 times farther away, so Neptune is 30 astronomical units from the sun. Just to give you a sense of scale here, we were talking about how long it would take you to walk, like the length of California. You know how long it takes you to walk the length of the campus. So like to walk from one side of El Camino to the other takes about 10 minutes. To walk the length of California, we said, takes about a week and a half of nonstop walking. If you were to start on planet Earth and walk until you got to the sun, it would take you 4,000 years of walking. So the idea that like, you know, this is an easy distance to conceptualize, it's not. This distance is very big. And these distances are only going to get much bigger from here on out. Before we move on, let's talk a little bit about the solar system. So we have this picture here. It's a really good picture. It lists all 8 planets. So there are not 9 planets. There are only 8. Pluto is not a planet. Pluto does not count as a planet. Pluto never should have counted as a planet. We'll get into that in the very last week of class, but I'm going to give you a sort of the Spark Notes. Do people still use Spark Notes? I'm going to give you the Spark Notes version here. But basically, we have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. So this is the order that the planets are in. This is an order you're going to want to memorize. We'll talk about each of these planets in their own sort of, well, no. We're going to group Mercury, Venus, Earth, Mars together as one discussion, and then we'll talk about Jupiter and Saturn as one discussion, and we'll talk about Uranus and Neptune as one discussion. But we'll spotlight on each one of these, so we'll have some time to talk about each of these. But this sort of brings together the question, well, why are these planets? Why is Pluto not a planet? What is a solar system? What is a planet? So I have a couple of definitions for you. You may want to pause the video and write these definitions down in your notes, because we're going to be talking about a lot of stuff here, and especially in these very first few lectures, I want to get some definitional stuff out of the way. And the reason why I want to get it out of the way here is it doesn't make sense for us to talk about things and you have no idea what we're talking about. So in order for us to be on the same page, I've got a whole bunch of these definitional slides just at the start. So when we talk about the solar system, we talk about our star, the sun. So remember, the sun is a star, and the collection of objects that are gravitationally bound to it. So what does this mean? Well, anything that's in orbit around the sun is part of the solar system. So the planets are part of the solar system. We have moons that orbit planets. So the planets are orbiting the sun. So it's part of the solar system. Dwarf planets like Pluto orbit the sun. So that's part of the solar system. We've got asteroids that orbit the sun. So those are part of the solar system. We have comets, also part of the solar system. There's some dust that's in orbit around the sun. That's also part of the solar system. We actually have an object that's in our solar system that didn't originate from our solar system. Oumuamua, I think that's how it's pronounced, is an asteroid or a comet that originated from outside the solar system and recently passed by the sun, and now it's on its way out of the solar system. So we do get visitors from time to time. They're very uncommon, but it's super exciting when it happens. So what is a planet? There are 8 planets, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. And a planet has 3 conditions on it. So you need these 3 things to be true in order for something to be a planet. A planet needs to orbit the sun. It needs to be round in shape. So the correct term here is spheroid, but I'm going to use the word round because that makes it obvious what I'm talking about. And it clears the neighborhood of its orbit. So what does this mean? Around a planet, you're not going to find a lot of debris. If you find a lot of debris around a planet, that means that when the planet formed, it didn't take all of that debris and form a compact object out of it. Some of that debris is still floating around. So for example, Pluto, which is a dwarf planet, does not clear the neighborhood of its orbit. If you take a look at where Pluto is located, there are a bunch of comets around Pluto. And so because Pluto doesn't dominate the gravity in the region that it exists in, it is not a planet. There are 5 dwarf planets. So Pluto is one of them. There are 3 others in the same region that Pluto is in, and there's 1 in the asteroid belt. This is going to be the last thing we talk about, so I'm not going to touch on it too much here. And then a moon is any natural satellite that orbits another object. So if it's orbiting something other than the sun, it is a moon. So planets have moons, dwarf planets have moons. It's possible for asteroids to have moons. We haven't seen any, but if a moon had something in orbit around it, that would be also a moon. We would call that a sub-moon. Earth has 1 moon, but right now it actually has a micro moon is what we're calling it, or a mini moon. It has an object about the size of a car that's in orbit around it. That object will be gone soon. It's not a permanent fixture. So planets from time to time do pick up other objects that are in orbit. At last count, we have 219 moons. But we have several candidates that we think are moons and just haven't confirmed. All right, so that wraps up where we're at for the solar system. In the next section, we're going to talk a bit about sort of the next step up. So where do we go from the solar system?